In this video, you'll learn about status quo and pivot designs and how to input them into SurveyEngine. You'll also see other ways of including respondent reference data to make your experiments more realistic and meaningful. It's important to respondents that their choices are conceivable. So when running an experiment where respondents have differing experiences with, say, cost and distance, that the experiments are placed within their experience. A common case is where you want to model the relative qualities, such as percentage change in travel time or cost, rather than the absolute change. So let's get started. We'll begin with a status quo experiment, which is really a special case of the opt-out. It just means that the respondent wants to remain with their current situation. And we could just label this your current situation. But it's better to repeat back to them what their current situation is in the context of the experimentally generated alternatives. This is a little bit more complicated as we first need to extract this information from the respondent, potentially transform it, and then display it back to them. So for the first part of this video, we'll just look at extracting, transforming, and piping data back to the respondents. Then using what we've learned, we'll apply this to the experiment. So in this example, we'll use our route choice experiment information: time, congestion, and toll cost for choice of route. So we'll create 3 questions where the users can describe their current situation, what their current travel type is, what their typical congestion is, and whether or not there's a toll and how much it is. Just a short aside on bringing user data into your survey. Using raw user data for calculations is often much more complicated than it seems. There's many exceptions that need to be handled when users input raw data. For that reason, in this example, we're going to constrain user input to be a selection from a set of known values. This makes transformation much simpler. We'll now transform these into textual descriptions, and this is done with a derived value. And we could do this on the fly, but this way we can record and audit what was actually shown, and we can make changes later without having to recode everything. We do this with Perl expressions, and these are simple if-then clauses mapping categorical values of 1, 2, 3, 4 into textual descriptions. Now that we have that data transformed, I'll show you how to pipe them back to the respondent. Now, anywhere that you have user output in questions, levels, or experiments, you can pipe the data back to users by adding the class expression to any piece of HTML. And any valid Perl expression within this will be evaluated and displayed in real time. In our example, this is simple. We just put the variable name to be evaluated, which, when the survey is running, will be replaced whatever the current value is. Previewing this, we can see that when we select input for time, congestion, and cost, on the next page, it shows the transformed textual values. And we're now ready to perform the same trick in our experiment. Moving back to the experiment screen, we'll create a 3 alternative experiment with the attributes of time, congestion, and cost. And this is identical to the opt-out. And as with the opt-out, our first 2 alternatives are unlabeled, and the third attribute has fixed empty levels. But this time, we're going to call the third alternative status quo. And instead of empty levels, we'll pipe our status quo variables in. And as before, we'll generate a simple design, although we don't actually need to, and see what it looks like. Now, in the layout editor, we won't actually see the calculated expressions because nothing's been input yet. But when we run the preview and enter our current status quo, you'll see them appear in the experiment. Pivot experiments are similar, but this time, instead of a fixed set of status quo levels, we'll vary or pivot the levels about the user's status quo. In our example, we expect different respondents to have fairly different travel times. So to make the experiment realistic, we'd like to vary the travel time within 20% of the respondent's typical travel time. So going back to our transformations, let's create 3 new variables from the input: plus 20, same, and minus 20. And these are simple calculations that just convert the respondent's input to a numerical value and then format that as a string. Going back to the experiment now, let's change the time for the third alternative to a 3-level attribute. Level 1 is the 20% less, level 2 is the same, and level 3 is 20% longer. We'll generate a design again as we've changed the experiment structure and see what it looks like in the preview. And as you can see now, when we input our status quo, the levels vary within 20% of our input travel time. There's a couple of subtle points I'd like to stress here. Firstly, the experimental design is now independent of how the levels are calculated and displayed, and we could change the calculations to be 30% or 40%. We wouldn't need to change the design. And secondly, it is good practice to store those intermediate process values, and we could have performed them on the fly, but this would be harder to audit and would require good record keeping. By using intermediate values, the transformed text values, this data is now stored alongside the choice responses. This method of using data to modify the user's experiment can be further extended to do more exotic things like hiding irrelevant attributes or performing on-the-fly calculations such as calculating a total price from a quantity and unit price. There's lots of tutorials on the website that you can download and inspect how these various ways of running status quo and pivot designs were done. Thanks for listening.